Well, we're glad to be back again this year and show you some physics magic. We decided this year to do everything that's cool. We have liquid nitrogen, which is 196 minus 196 C. That's 0 is freezing, and so 196, negative 196 is quite low. And so it freezes things quite rapidly, and if you're not careful, you can get frostbite. So you have to learn how to handle it properly. So we're going to have Maria Vaughn show us her demonstration, and we'll go from there.
All right, so here I have my whistling teapot. Usually, you boil water in this, and it takes about 10-15 minutes for it to whistle. I'm going to make it whistle instantly.
I don't recommend drinking this stuff. In fact, someone had, and they froze their stomach and ended up in the hospital. So, yeah, don't ever drink this stuff. It's not good for you. Okay, we're going to show the lead bells. Lead bells are very good material for a bell. But when you put it to liquid nitrogen temperature, it changes the sound. So we'll cool it down. It takes a while for it to cool down. Let it boil there until it stops boiling. Maria's going to go ahead and show us some other demonstrations by freezing different materials and showing you what happens to them.
So here I have some Tygon tubing. You can see that it is pretty soft. I'm going to toss my liquid nitrogen there. I have a lemon. Put that in there. A bouncy ball. Put that in there. I gathered some beautiful flowers. I'm going to toss those in there. Running out of room. Oh, and I had my balloon in there.
What I should mention is that liquid nitrogen is actually just the nitrogen and air cooled down to the point it comes to liquid state. And there is a way to make it to go down even lower so it becomes a solid, but it's only under a vacuum situation will it work that way. We couldn't show you that there because it's such a small demonstration, you'd have to be right up on the stand in order to see it. So, okay, here's the lead bell. Stop boiling. Still not my favorite bell, but it's time to get it. I want to eat it. Okay, we'll let that cool down. Warm up to room temperature.
All right, so I have that one's done. So I'll pull out my flower, my hibiscus. Kind of crunches. I have another flower. Let me grab it up, a better one. Like glass.
Reminds me of potato chips.
Okay. This guy's hard. All right, so this one, I'm going to smash. Hold them. Oh. Remember that was like, soft. And see if I can get my lemon. Here's my lemon. It's so much fun.
Okay, here we go. Before it was really bouncy, we'll see what happens now. Well, that was not planned. Okay, very good. Okay, do we have anything else to break?
No, that's it.
Okay, that's it. So next, Heroes Engine. a while back, we were told that we couldn't have anything with flames on the stage. And so in a kind of a fit of rebellion, we came up with a demonstration that we wouldn't have to use flames to do a demonstration. There's a thing that was developed by Archimedes called, I'm sorry, not Archimedes, Hero's engine. It was used, it was a container that you put a flame underneath with water in it, and then as it boiled, it would come out of the jets and start spinning. Okay, we're going to use liquid nitrogen to do the same demonstration, so here you go. I've got to put, oh, that's, carefully pour this in.
And you don't want to pour too much, because
I need a little bit more. So, right now it's open to the atmosphere, so as it expands, the gas expands, it's just coming out the top. When we put the lid on, well, I start feeling it come out of the vents here on the top. But to accelerate the expansion of the gas inside, I'm going to put it into room temperature water. And back with this more out front. Here goes. Oh, wow.
Okay, so now we're going to show how liquid nitrogen keeps away oxygen, I guess. That's a way. So I'm filling a beaker with liquid nitrogen, and hopefully it'll cool down. Here I have my light bulb. As you can see, it turns on and off. I'm going to break my light bulb. Oops. My hand.
You can only practice so much before we go through so many light bulbs. We broke it. Okay, we had another one, but what we wanted to show you that if we turn on the light bulb without the glass envelope on it, the light bulb, the wire in it will just burn out. It glows red and then puff of smoke, and then it's no longer there. But if we take that filament and put it in liquid nitrogen, because of the absence of oxygen in it, it will glow. So we're going to do that. I'm going to put a little bit more liquid nitrogen in here.
Of course, if I take it out, I suppose I could show it burn out now.
Okay.
And it burns out.
So not recommended, but you can see that it's the oxygen getting to the tungsten filament that causes it to burn out. Okay, very good. The next demo is LN2 and bubbles. Okay. Maria's going to take the liquid nitrogen she has here into some warm water with a little bit of soap in it. Okay, I guess we did it. Okay, quick pop some bubbles. There we go. Get some of these bubbles and pop. First time I did this, this thing shot up in the air about 6 feet. So we toned it down some, so this is a good demonstration. We show the expansion of liquid nitrogen. Believe it or not, it expands about 700 times its original volume. And to kind of show that, I'm going to copy the demonstration from Brigham Young University. And what I'm going to do is I'm going to take little cup of liquid nitrogen. It's about a third full. You don't want to put too much in it. And you're going to put it on here. And then the bottom of this, I have some chain. And so what I'm going to do is put this on. Taking the cork out here. And put this on. The gas is still expanding in there, but because I have this cork out, it's not going to start filling it up. And so when I dump this upside down, all that liquid nitrogen will fall in a chain. Then it will expand to this orange bag here will start expanding it too. So we'll go ahead and flip it over. This is about the amount of liquid nitrogen I have in that cup. And so if you imagine 700 of these stacked up on top of each other, then you got an idea how much volume we're talking about. Maybe I talked too long. Not too bad. Not too bad. Last time we did this in practice, it popped off the top and the thing deflated, so this worked out pretty darn good. Our last demonstration, I have to make sure I got approval by people here. Okay, put some liquid nitrogen into this soda bottle. I'm not going to put too much because you don't want too much gas in it. This is our LN2 rocket. We like it so much that we decided to make it our last demonstration.
Now we have a funny story. We were practicing with this yesterday, and we're like, what if we put some money in there, like a dollar bill? Now we don't have a dollar bill. Someone had a $10 bill in their pocket. And he rolled it up and placed it inside, and it shredded to bits. So it's very expensive practice.
Actually, I want to give a plug for Cal Poly Credit Union. We were able to piece all the pieces together in 10 hours.
Okay, here it goes. We're going to shoot it over towards that wall. Anyway, some people put the caps on these things and they explode. You don't want to do that. So you can get in trouble with the law if you do that. But if you do this, it should be straight. Here it goes. Still enough pressure, I can feel it. Okay.
No one got hurt here, right? Everything's all right? Okay, good. They were worried about us doing that demonstration, so thank you very much.